all hear me? Perfect. So, good morning, everybody. I am Vitor Cora, and I'm going to be speaking about cloud networking, taking control of it, okay? So, just some house cleaning. My idea here is for us to have a 20-minute talk, give or take. Sometimes I speak a little bit too much. And 5 minutes of Q&A. If we go a little bit above this time, I'll be in the booth, the Troy Michael booth, so you can comment me and question, and we can speak more at any given time, okay? So before here, let me introduce myself. So as I mentioned, I'm Vitor Cora. I'm a senior cloud solution architect at Troy Micro, and I'm also a network SME, so solution matter experts. So my background, back in 2014, I started working with on-premises networking. I joined Trend in 2018 after the acquisition of Tipping Points because we needed more knowledge in networking. Started my transition to the cloud in 2019, and it's been 3 to 4 years now that I don't want to see boxes anymore. So my idea here is going to be speaking to you all how you can leverage all your knowledge, be it from previous on-premise routing or even build it from scratch, and then retake control. So let's start talking about architecture. So when we go for architecture, we are going to have 3 main types of architecture. The first one, we could say EC2 base, VPC hosted base, or lift and shift. This tends to be the first contact that the customers, they have in a migration, a modernization from the on-premises to the cloud. Some aspects here for you all to know and to remember, they're mainly VPC hosted. So when you launch an EC2, you're going to be needing to have an VPC for it. They tend to be slower to move, and the applications on it, they tend to be more monolithical. So for anyone that don't or that are not used to monolithical, so monolithical applications are those type of applications that any minor change can bring a big problem. So old softwares that used to take 6 months, a year and a half for you to have an update, they tend to be monolithical because any minor change tends to bring these long Q&As, and you need to guarantee that it's still stable. The second interaction that customers tend to have in the cloud, here just bringing some of the buzzwords of the moment like DevOps, container, and Kubernetes, tends to be the containerized. So it doesn't change a lot from what we're used to see in the lift and shift and EC2, but you're going to start to see microservices appear in here. So this kind of infrastructure, it's easier for you to scale. It tends to be a little bit more cheaper, and you can start to break it in smaller pieces. So CI/CD pipelines, they tend to enter in here, what makes the time for you to launch a new application, to launch new services, way more short, let's say like this. So these years tend to become months, and depending on the company, can be a month or even weeks. And we could say the last interaction or the newest interaction, let's see what AWS is going to bring us in the future, but it will be the serverless. So I'm reference here Lambda, because Lambda tends to be the biggest one. So we could say here the flagship for it, but we could bring also to the table FortiGates. So in this here, one of the main points is that primarily they are not VPC hosted. So you can see here in the top, the bottom right corner, how the architecture or topology tends to be. It's all flying. So you don't have a VPC, you don't have an environment that's hooked to. But you can integrate it with VPC endpoints to an environment, a more control environment, and that you don't want it to be completely or directly connected to the internet. So now, why? I wanted to have this slide here in our talk because most of the people tend to go for the Lambdas, the FortiGates, and why I'm going to go back a step as an instance and hook it to a VPC. So when we speak about no VPC or no any customer own an infrastructure, it's easier to deploy. It's simpler. You don't own any infrastructure. You don't own routes. It's all done publicly, let's say like this, and it's less friction because you don't need to be caring about the infrastructure itself. And when we go with VPC, the why, so why go for it, we are going to have more control. You're only going to expose to the internet what needs to be exposed. As an instance in here, if you have an S3 bucket, the traditional conversation in between a Lambda or an EC2 or whatever service that you have with it, it's going to be through the internet. It's still HTTPS, but it's still going through the internet, even both services being on AWS. But when you hook it to a VPC with a VPC endpoint, all this communication is going to be private. So in this, we are going to start to get some advantages. You know that each and every, so whatever traffic or data that you take out from AWS, you pay for it. You're going to have internet latency and all. So when we bring it to a VPC hooked environment, we are going to have a smaller latency and we are going to have a smaller data costs. Okay? So let's move forward here for some services. Before I start to speak about routes and all, I want to show you also how some of the services work. And moving from this point in here, then we can get both points and hook them together by the end. So the first group of services that I want to show you all is going to be gateways. So what is in gateways after all? So the three main ones that you're going to all be seeing in the environment is going to be internet gateways, IGWs, NAT gateways, NGWs, and VPN gateways, VGWs. So some important points, gateways tend to be the place where your public NAT is going to be happening. So this is something that really bugged my mind and is going to help us in the future and even for you all to take control. Your NAT is done in the gateway itself. So when you place a public IP in, could be your ELB, could be in your instance, they don't have a public IP. They have a tag. So whenever someone is contacting you and calling for that IP, it's going to be natted in this gateway. So this is super important because this means that after it goes through the EGW, when we are in internal communication, we are going to be intercepting locally routed IPs, so private IPs. And it's important because if you don't know what are your targets, you are not going to be able to control this traffic. The next one is going to be load balancers. So one important point about load balancers is that you're going to have two stages. Let's say that the first stage is going to be the public or the inbound, and the second one is going to be the private or the egress, or outbound. We can call it them in all these different ways. And the second stage is where your target groups are going to be. Some important particularities from this point here, from the load balancers, is that each and every communication after the load balancer to the target group, it's a private communication in between them. So what does it mean? That looks like pretty basic or pretty straightforward. But when you inspect the communication in between the load balancer and the target group, the instances are targeting the response to the load balancer, not to the public IP or to the caller itself. It's a load balancer that's going to reply back to that user. So what does it mean? If it's a public initiated communication or call, so imagine here a banking app that you're speaking to it, so you are calling the services. Then you're going to be speaking to the ELB, and the ELB is going to be speaking to the targets, to the instances. When they reply, instances communicate to the ELB, and the ELB reply to you. But when this instance starts the communication, has this outbound or private communication to the internet, it's going to go directly to the internet. So as an instance, if you have a route 0.0.0/0, so a default gateway route, it's not going to go to the ALB or the ELB. So this is a pretty good way for you all to be able, as an instance, to segregate your private and public means of communication. Gateway balancers. I would say that this is the new kid in the block. Some of you may have heard about it, but gateway load balancer, just to recapitulate in here, it's going to be a service for you to build and manage virtual appliances. So a lot of you may have seen it. So third parties, we have a solution that's going to be sitting in this space in here, but you can build your own, and you can use gateway load balancer to seamlessly bring it to the table, to bring to your flow of traffic. Some important points. When we were mentioning load balancers, the traditional ones, we had the two stages. This here looks super similar, but works completely different, because you need through route tables and through routes to make the communication flow. So if you send traffic to a gateway load balancer and you don't set the next hop, it's going to get lost. If you set it wrong, it's going to get lost. So you need to pay attention in how this traffic is flowing, because when the traffic comes from the inbound to the gateway load balancer, when you go for the VPC endpoint, it's going to send through a Geneva tunnel the information in. It's going to reach, as an instance, AWS firewall. And then it's going to send back the traffic. And it's going to throw the traffic in the subnets where the endpoint is. So if it doesn't know where to go next, you are going to lose your communication. We're going to enter in a little bit more details later. So now, let's speak about some other noteworthy services, as I'm not going to go super deep on them later on in our architecture talk. I just separate here VPC peering and transit gateway, some noteworthy parts of it. So first one, VPC peering, is the oldest service that we have to make two VPCs communicate. What is important about it? One-to-one communication. If you have two VPCs, they need to speak with each other, VPC peering is perfect. If you have three, and you need to have any type of transit peering, it's not going to work. VPC peering doesn't work for transit communication. And then we can bring into the table transit gateway. I remember that for a time, it was a ruckus. Everybody wanted to have a transit gateway because you could do one-to-any. You could peer transit gateways in between different regions. That's something that VPC peering could do in the past. So we could have a VPC in the west one and one in east one. Transit gateways with this kind of peering added this, VPN, so security solutions. We even built something at the time for it. So transit gateways allow this transit peering and do this one-to-any. So you don't grow factually. So it's pretty good for you all to know. And now, let's talk about routing. This tends to be the part that people bring the air in and say like, okay, what now? Let's try to break it through in two different points. First one, route tables. And then let's really go to the route itself. So route tables, two main kinds of it. First one, edge association. This is pretty new. We could say it has 2 years, give or take. And edge association allows you to associate a route table directly to the internet gateway or to the VPN gateway. Do you all remember that the gateways are the ones responsible for doing the NAT? So after the NAT's done, the traffic was routed locally. So if you were aiming for a load balancer, it was going directly to a load balancer. If you were aiming to an EC2, it will go directly to the EC2. You could not intercept the traffic midway. So if you had a single VPC topology, architecture, or design, you had no control over the public. You needed to have like a transit gateway, and this added costs. So with this simple solution that AWS brought to the table, you were able to control. As an instance, you can just do a VIR, a VPC ingress routing, or an edge association, and you can bring in AWS firewall. It's straightforward. Don't break your communication. It's pretty sweet. And the most traditional, subnet association, the association to subnets. It's the most traditional one. And in here, it's going to leave the main route table. That route table that you don't associate to no place, and for some bizarre reason, your subnets are still working. Like, okay, my routes are going around and I haven't done nothing. this is where, as an instance, the main route table is going to live. And now let's go for routes. So the routes inside these route tables, they are going to be composed of two main things: destination and targets. See destination as or generic. What would be a generic route? As an instance, O.O.O/O. So O.O.O/O, default gateway. If you don't know where to go to this place. Or something specific, 10.1.0.50/32. This is a host, and you can go in between all the flavors. So you could have a /24, you could have a /16, you can have whatever you want in the middle of the way. Here, it's where I leave the more specific routes. This is a service, this has something around half a year, give or take, that AWS released the service, and this was some big change for our board security or even routing, because now we can control the local route. So not just intercept what's coming from the gateways, but also you are able to control in between subnets how the traffic is going to move. And targets are going to be local, so routed locally, so next hop, the desired instance, you can send to endpoints, network interfaces, services. This is where, as an instance, your S3 route, if you're using VPC endpoint, is going to live. This is where, as an instance, AWS firewall route is going to live. Or transit gateway attachments, just to give you all some more points about it. And now, just for you to see some examples of the routes, so as an instance, we have a /32, host IP, /24 and 16s. These tend to be VPC seeders and subnet seeders, and O.O.O/O, the default route. That you use it for internet, or I don't know, just send to the next hop, it will probably know. And then what? So in here, some examples. So local, as I have mentioned, locally, IGW, direct route to the internet, NGW, private route to the internet. So if you don't have a public IP on the instance, you need it for it to reach the internet. VGW, route to your on-premises, ENI, EC2s, virtual appliances, and all. VPCE, route to VPC endpoints, and TGW, transit gateway. They're always going to start with something like this. And now, let's start to play around. This is the part that I like the most. Coming from the architect words, I like to see what I'm speaking. So in the left corner, right corner for we all in here, you're going to see a VPC with a simple ELB and out scaling group. So your traffic is all being targeted at here, the ELB. So whenever it enters, be it for the DNS or the public IP, it's going to go straight there. And then it's going to reach your instances. But imagine that now you want to add AWS firewall, and could be your service that you're building to intercept traffic, or anything to analyze metadata, or even a third-party solution. The moment that you add and create those two services, here comes the trick. Nothing happens. They're going to be literally flying, because you need to be the one to hook them in. If you don't do anything, they're only going to be consuming money. So let's take a quick glance in here. By default, all the gateways, they have a route table associated with them. And it's going to be only VPC seeder local. If you look around, you're never going to see it. So what you all need to do is create a route table. You're going to have in there subnet association, edge association. Under edge association, you're going to need to select the internet gateway or the VPN gateway that you want to control and to associate that route table. And doing it, you're going to be able to, in this instance here, use ELB seeder as the targets, and then as destination, VPC endpoints that's responsible for the AWS firewall. This is how you hook it in. You can see in here that doing this, by default, all subnets are going to have or are going to be under the main subnet. So we are going to have a local route. So your traffic, inbound traffic, is going to the firewall. In here, we have two of these noteworthy services that we have been speaking about. The first one, edge association. The edge association associated this new subnet, this new route table that we created to the internet gateway and made possible the interception of all the incoming traffic. And then we are speaking about more specific routes because the ELB seeder, this subnet seeder, or it could be even a host that you're placing there, this is a more specific route than the VPC seeder. So we are going here from more specific to less specific. You can see that I still have the VPC seeder over there. And this is the more specific route setup. So now let's jump one more step. Now let's add the second point of contact in here. You can see that now I'm still going to be targeting the ELB seeder because that traffic is still intended to the load balancer. Doesn't matter if I intercept it or not in an AWS firewall, a third-party IPS, then as an instance you bring a DDoS or whatever you want to bring in, the target is still the same. You're not breaking the logic. You're not adding new public IPs to it. So this way, we are going to be still targeting ELB seeder. But now we're going for VPC endpoints gateway load balancer. So we're going one step down. In the endpoint, we can go local. The next hop is going to be the ELB. So after local, we are now here in the ELB. For the ELB, remember, they're going to be speaking locally. The ELB to their target groups, they speak one-to-one. So you don't need to really bother about it. So you may keep here local, and here in the bottom, local as well. Just for you all to see, I have added here the o.o.o/o to the net gateway, just to guarantee that any updates that this cluster needs to get, it's going to be able to grab it. But now, in the outbound, I added here a route that's not anymore directly to the internet gateway, to the AWS firewall. So this way, I can use the same flow of information. In my specific case, that I tend to work more with IPSs, I like to do firewall IPS, because this way the firewall kills everything that don't need to exist. As an instance, if I don't have any SSH, I can drop it in firewall, and then in the IPS, I'm going to be looking for the real deal, the things that really make sense, the attacks. And then afterwards, send it back to IGW, and my loop is closed. So if you all want to take away from this, this is what I'm teaching to the new guys that are coming, and new gals that are coming to this cloud networking words, is always look for the loop, close the loop. Because if you don't close the loop, the information is not going to get there. Doesn't matter if you have a perfect inbound, if your outbound is incorrect, you're not closing the loop. Whoever have called you is not receiving the answer back. And now, what Trend Micro has to do with it? I promise you all, only a slide in here. So, as I mentioned before, my work basically it's with IPSs. So Trend Micro have leveraged Gateway Load Balancer to create a service where you don't need to place any virtual appliances in your environment. So basically it's seamlessly. So you're not going to have to deploy virtual appliances, take care of all scaling groups, and nothing like this. And you can go directly to the meats and potato, the nitty and gritty. You're going to have all the power from Trend Micro. So we have more than 23,000 filters. And one super important thing, we are backed by Zero Day Initiative. So what is Zero Day Initiative? It's our buggy bounty program. And we are responsible for 2 out of 3 new vulnerabilities that are found and disclosed in the wild. And we feed all this information to the service in here. So you're going to be protected even before you know that this vulnerability exists. And if you want to know a little bit more, try or use, we are in the AWS Marketplace with 30 days free trial, and we have here also a QR code directly to our documentation where you can read a little bit more, learn a little bit more, and I'll be the whole day in the Grand Hall we are going to be going through at 2 to 2:30. Nicole, correct me if I'm wrong. We're going to have a demo, so a quick run through of the Cloud One platform. I'm going to be speaking a little bit more about it and zero-day initiative, and we have CFTs. This is where you guys can get, or try to get at least, a Bose headset. So it's a 10-minute challenge, no prior knowledge needed. Just go in there, try your best. We are there to help you all to understand and guide you through the console. And I think that's it that I had prepared for you all. Any questions? Thank you. Please.
Yeah, very interesting to know that, like you said, always free here in AWS marketplace. What does that mean?
Okay.
Yeah, I'm very interested in that. It's a get started day with a free trial that I know 30 days. But that always free here in AWS marketplace.
It is exactly what's saying in there. So for some of the services, as an instance, we have conformity, that's our CSPM. If you're running it for any accounts that has less than 250 resources on it, we don't bill you for. Doesn't matter if you're using us for a month, a year, or 10 years. And one of the reasons behind of it was like a lot of customers, when they started to look for CSPMs and all this kind of tools, they wanted to have it for their whole organizations. So the top of the chain, the top of the organization, the control tower, and also where the applications are. But they didn't have like 2 grants, 3 grants, 10 grants, doesn't matter how much people are billing for an account that basically had nothing, or for the logs accounts. So we want to assure that each and every customer, doesn't matter how big or how small their accounts are inside the organization, they're going to have the same level of protection. So this is the always free tiers. We have it for this one. We have for open source security. That's 15 projects that you have in your Git, and also for file store security, that in 1 hour, if you scan less than 20 objects in that scanner, you don't pay for it. So you pay in between 21, if I'm not mistaken, it's 100s, and then 100 and 200s. So you're going to be billed by the tier that you are in the marketplace. Was I able to answer your question?
Okay, thank you.
Thank
Below certain
thresholds.
threshold is free.
Exactly.
Any other questions? Thank
Perfect.
you so much, Rita.
A last announcement. This year is the first interaction of what I'm building of a networking course. So all the idea for this came from internal training that I'm starting to do with some of my peers. So the idea is to start to give it out to the community. So if on my LinkedIn afterwards for you all to be able to follow through or to get like this presentation, it's all public material. Just let me know. It's going to be a pleasure to speak to you all or to help you all in this journey.
Thank you, Rita.
Thank you.